Hey, I bet I can launch a rocket better than you.
Oh, yeah?
Yeah.
Let's see whose rocket brings all the boys to the yard.
Okay, we will.
Hi, James McCoy. I'm going to keep track of how long your rockets stay in the air.
Alright, the Mentos is almost in. Ready? Go!
Alright.
Did you catch that?
We'll see whose rocket goes farther.
I think mine wins.
Okay.
So, who's went further?
I don't know.
Why don't you know? Why are you playing tic-tac-toe?
Chillax.
Why did you record that instead of using a stopwatch?
The Stop Pros do it.
Don't worry guys, we can solve this with calculus.
Well, based on the data that Katie has given us, it is possible to determine whose rocket stayed up in the air longer. Taking a look, we see that acceleration is given at negative 16 feet per second squared. So negative 16 feet per second squared. To get the velocity, all you need to do is take the antiderivative of the acceleration function. So it would equal negative 16t plus c. Well, taking a look back, we see that velocity is given at t equals 2. So you can plug it in to find the value of c. And in this case, c turns out to be 24. So the velocity function is negative 16t plus 24. To get the position function, all you need to do from here is take the antiderivative of the velocity function. Which would equal negative 8t squared plus 24t plus c. Since the height is given at t equals 1, you can plug it in and find the value of c. Equals 16 feet. So if you work it all out, I think c turns out to be 0. So the original function would just be negative 8t squared plus 24t. To find how long it stayed in the air, you just factor it out, say it equals 0. So my rocket stayed up in the air for 3 seconds. Let's see how long James's rocket stayed in the air. Acceleration is given at negative 32 feet per second squared. So negative 32 feet per second squared. To get the velocity, you just take the antiderivative of that, which would equal negative 32t plus c. Since the velocity is given at a certain time, you can plug it in and figure out the value of c. Oops, plus c equals negative 24. So you work it out, c turns out to be 40. So the velocity function becomes negative 32t plus 40. To get the position function from here, you just take the antiderivative again. So plus 40 dt, which would equal negative 16t squared plus 40t plus c. Since the height is given, you can also plug it in and find the value c. And it equals 24. If you work it out, I think c comes out to be just 0. So the original position equation just turns out to be negative 16t squared plus 40t. Well, to find out how long it stayed in there, you just factor it out and set it equals 0. Equals 0, t turns out to be 0 and 2.5. So James's rocket only stayed up in the air for 2.5 seconds, and mine stayed up in the air for 3 seconds. So I win. In your face, James.
It doesn't matter what comes, fresh goes better in life, with mental expression full of
With mental expression